When you picture the deep, deep ocean, what comes to mind? Probably crushing pressure, right? And total, absolute darkness. But what about sound? Well, it turns out the way sound works down there is just as extreme and, frankly, just as mysterious as everything else.
Right, far from it. In fact, it's a surprisingly noisy place. But that noise, it doesn't always follow the rules we expect. And getting a handle on that is pretty much the key to understanding the deep.
So before we get to the weird stuff, we've got to understand the basics. How is sound supposed to work in this massive, open space that covers most of our planet?
This is just fundamental physics. You see, water is way, way denser than air, so sound waves can just rip through it with incredible efficiency. We're talking about 4 times faster. And this one simple fact changes everything. It turns the ocean from this vast, empty void into a massive, living network for communication.
And you see this in action everywhere. I mean, for animals, it means a blue whale can sing a song that travels across an entire ocean. For us, it's how a submarine can see in total darkness, basically painting a picture of its surroundings using nothing but sound.
So scientists discovered there's this one specific layer in the ocean where this effect gets totally supercharged. They call it the SOFAR channel. That's short for sound fixing and ranging. Down there, this perfect storm of temperature, saltiness, and pressure creates a kind of trap for sound waves. It keeps them from escaping up to the surface or down to the seabed and just funnels them horizontally. Think of it like the ocean's own natural fiber optic cable, but for sound. It's amazing. Okay, but here's the twist. What happens when that perfect sonic highway just hits a dead end? Because in some parts of the ocean, the rules that make the SOFAR channel work just completely fall apart.
And this is really the heart of the mystery. In these strange zones, sound doesn't travel far at all. Instead, it gets all distorted, bent in weird directions, or sometimes it's like the water itself just swallows it whole. It just vanishes.
So what on earth could be causing this? Well, the answer isn't some mythical sea monster. It's something even wilder. Extreme high-pressure physics, especially in the very deepest parts of our world.
Yeah, this whole phenomenon is most noticeable in the deepest ocean trenches, places like the Mariana Trench. I mean, down there, over 6 miles deep, the conditions are so unbelievably intense that the nice, stable layers you need for the SOFAR channel, they're just completely scrambled.
Now this is where it gets really interesting. That hydrostatic pressure at the bottom, it's so immense, it literally compresses the water molecules, changing their physical properties. That, in turn, creates these chaotic, sharp changes in temperature and salinity. And what you end up with is a jumble of dense, shifting layers of water that act less like a highway and more like a maze of acoustic funhouse mirrors, just scattering and absorbing sound waves left and right.
This chart really puts it all under perspective, doesn't it? Where the SOFAR channel is this perfect sonic highway for clear, long-distance sound, these deep trenches are the exact opposite. They are acoustic dead zones. Sound goes in and it gets trapped, weakened, and just doesn't come out right.
So you might be thinking, okay, cool physics, but this isn't just a science experiment. These acoustic dead zones have some pretty profound and sometimes pretty dangerous real-world consequences.
I mean, just imagine for a second you're a sonar operator on a submarine. You cruise into one of these deep trenches, and all of a sudden your sonar, your eyes in the dark, goes blurry. The signals coming back are weak, distorted, maybe they don't come back at all. For a moment, you are acoustically blind. And in a place with total darkness and crushing pressure, that is a terrifying situation.
And we have to remember, we aren't the only ones trying to get around down there. The animals that call the ocean home have been dealing with these acoustic quirks for millions and millions of years.
So how do they handle it? Well, from what we can tell, it seems like they have 2 main strategies. Some species, especially the ones that really rely on long-distance calls like certain whales, they just seem to avoid these areas completely, a total no-go zone. But for others, these acoustic shadows could actually be an advantage. What a perfect place to hide from a predator or to ambush prey, using that weird distorted soundscape as a kind of natural stealth mode.
You know, when you put all of this together, it really forces you to rethink what we know about the deep ocean. It's a place that doesn't just challenge life, it challenges the very laws of physics as we experience them up here on the surface.
This quote just nails it. It's so true.
We found life thriving in the most ridiculously extreme conditions you can imagine. But in those exact same places, one of the most basic physical forces we know, sound, is just completely and utterly defeated.
And that's really the big takeaway here, isn't it? Every single time we send a probe down, every new sensor we deploy in these trenches, we just learn how much we still have to learn. The deep ocean isn't just another place on the map, it's a whole new frontier for physics.
Which, of course, leads us to that final, massive question. If something as basic, as fundamental as sound can be completely swallowed by the abyss, what other secrets, what other phenomena are still waiting for us down there in the silent, crushing dark?